So Physics HL12, the answer to question 5, which was the toughest question on the quiz today, has a couple steps that we have to follow. And I said it was an IB question because probably on the IB exam they would have broke it down into multiple parts, but I wanted to see how well you guys thought if I just put it all together. Okay, so the question is asking us to find the line spacing in that grading, and they gave you this value. Plus, they told you that the wavelength of the laser is 650 times 10 to the minus 9 meters, or 650 nanometers. So using all this, we have to be able to solve for the grading. And you know that this is the formula for constructive interference with multi-slit diffraction, d sine theta equals n lambda. All right, the first step is we have to try to get to d, but we don't have theta. So step number 1 is to calculate this theta using 20 centimeters and 5 meters, and the fact that this is the second order diffraction. I can calculate that angle. All right, so tan theta is equal to 0.2 meters divided by 5, opposite over adjacent, gives me an angle of 2.29 degrees. So that would be 2.29 degrees. Okay, I can then use that formula to find D. Okay, so D would be the line spacing. So N, which in this case is going to be 2 because it's the second order maximum that they had that 20 centimeters to, times lambda, which is the wavelength of the laser, divided by sine of 2.29, gave me 3.25 times 10 to the minus 5 meters. 32 micrometers would be the spacing of one line in that diffraction grading. So one of those lines has that spacing, okay? Or the spacing between two subsequent lines is that distance. So knowing that one line is that thickness, I can calculate how many lines fit in a centimeter by doing this, okay? 1 centimeter, which is 0.01 meters, divided by the thickness of one line gives me 308 lines. This is conceptually the hard part. You know, how would people connect this with this? All right, and that's why I called it an IB problem. Would you know to take 0.01 meters divided by that length in order to get the total number of lines that fit in a centimeter? Okay, tough question, but a good one. Worthwhile going back and practicing it a few times to play around with, because that's a really toughie.